Truro, Nova Scotia, working with Scott White on blueberry, Japanese knotweed.
All right. Okay, good. So thank you for the introduction. So I'm going to talk about the effective seasonal herbicide application timing on Japanese knotweed. So just a few objectives for this presentation. I'd like you to walk away with an understanding of some of the problems caused by Japanese knotweed, an understanding of the advantages of using varied seasonal timings for herbicide applications, and I'd like to hopefully give you some optimism for Japanese knotweed management. So let's begin. So there are four kind of key concepts about knotweed biology. It is polycarpic, meaning it flowers multiple times without dying. It is herbaceous, meaning no woody tissue. Perennial, meaning it would live relatively indefinitely until something kills it. And it is rhizomatous, meaning it spreads through underground stems. So it's from Japan. So in Japan, it's a primary colonizer of volcanic slopes, and there it helps to stabilize soil aggregates and attract other species to the area. It sounds like a model first in plant, and it's really small in Japan. However, once you move to Nova Scotia, it tends to occupy very different habitats, including the nooks between asphalt and building foundations, people's yards and large swaths, as well as riparian zones, interfaces between land and water, where it tends to do quite a bit of damage. So, reproduction. It's thought to only reproduce asexually in Nova Scotia, so through the rhizomes that you saw on the previous slide, as well as through nodular stems that you see here. And there are some kind of seeds that are always produced, but I dissected them, and Todd Larson did a few tests, and they were just found to be non-viable. It's just a bit of history. It was introduced to Europe and North America around the 1800s, and it saw very widespread use. People used it to mark property boundaries, to hide their outhouses, privacy curtains, stuff like that. But it fell out of favor around the 1920s when the problems associated with it became well known, like its very aggressive growth. Unfortunately, due to that widespread use, it came to occupy an absolutely massive range of habitats before it got classified as invasive. And because there aren't any significant natural predators in North America and Europe to keep the population in check, it absolutely spiraled out of control. So, why is this plant a problem? So, I've got a quick video. So, I think knotweed follows a basic invasive species introduction curve, where it kind of goes from adaptation to widespread proliferation, and then widespread awareness. Unfortunately, we're right here now, and that means that it's expensive to deal with, and that it's going to be much harder to get it all. So, now why is this plant a problem? So, this was just taken from April to the end of May, and as you can see, the bamboo-looking stuff is the knotweed. It absolutely takes off, and the native plants beneath it don't really stand much of a chance, and the knotweed says, "See ya, buddy," and then it just completely dominates the area. So the big issue there is knotweed generates a dominant seasonal canopy of about 300 centimeters, and it reaches that by about the middle of June in Nova Scotia. This shades the plants below it and often leaves bare soil exposed because there's no plants there to hold anything together or slow down water. This unfortunately leads to accelerated stream bank destruction, along with increased sediment loading in streams, along with the leftover stems causing interference with water management infrastructure like ditches. So this plant is a big problem. So what does the existing management literature tell us? So we know that the herbicides glyphosate, triclopyr, and imazapyr can show control within 1 to 3 growing seasons. McHugh kind of looked at doing mechanical control, and they estimated that you'd need to cut it about 17 times in over multiple growing seasons just to get it down. Last year I talked about how cutting followed up by herbicide application to the regrowth can be successful for reducing stem density, but what we were lacking is information on how various herbicides perform at different seasonal timings, such as the peak height window as well as fall, sort of in September. So what I set out to do was to determine the ability of the imazapyr, aminopyrrolide, glyphosate, as well as aminocyclopyrrochlor plus chlorosulfuron to cause knotweed stem density reductions 1 year after treatment when spot applied, either at peak height, which is in the middle of June, or in the fall, which is towards the end of September. So due to the size of available existing knotweed patches, we had to separate them into 2 experiments because it's an issue with land ownership and risks of public interference. We need to make sure that we get enough replications and to make it good. So, site description. So I established 1 by 2 meter plots in Antigonish and South Maitland, Nova Scotia. In Antigonish, it's on the Wrights River floodplain area. It's got large contiguous knotweed stands scattered all over the place. And in South Maitland, it's in a client of mine's yard with very large knotweed stands. I established 4 to 8 replicates depending upon my available space. So for treatment application, all herbicides were spot applied using a CO2 pressurized research sprayer like you saw with Hugh earlier. I used an air induction nozzle to minimize spray drift as much as possible. And then I sprayed the plot until all leaf surfaces were wet but not running. So these were our treatments in the 2 experiments. So we have a control where we do absolutely nothing. Then we have imazapyr, aminopyr, the glyphosate, and the Truvis, which is the aminocyclic pyrosulfuron at the rates you see on screen. So for design, the experiments were arranged in a completely randomized design, and I had the hypothesis that knotweed treated with a herbicide will have significantly reduced stem density 1 year after treatment when applied at peak height, as well as in the fall when you just compare it to doing nothing. I did my analysis in Minitab 18 using an ANOVA to compare stem density at each time period, and I used a Tukey's test to determine significantly different means with the significance threshold at 0.05. So, what did we find? So 1 year after treatment for the peak height application, we saw stem density reductions for imazapyr and glyphosate. However, for Antigonish. However, in South Maitland, we saw reductions with imazapyr, aminopyrrolate, and glyphosate. And we'll come back to that aminopyrrolate a bit later. So, just some graphs. So what you see here is at the beginning of the experiment, peak height 2017, no significant differences. However, once we move to the 1 year after treatment, you see imazapyr has almost completely taken it out, as well as glyphosate. So, just a nice visual for you. In the control, you see lots of happy, healthy knotweed, but in the imazapyr, it's heavily damaged, and in the glyphosate, it caused significant dwarfing to it, and it probably would not survive another herbicide application. So, for the fall timing, what we saw is 1 year after treatment, knotweed treated with imazapyr, aminopyrrolate, and glyphosate had significant stem density reductions in both locations. So aminopyrrolate appeared to work more consistently. Okay, so just some results for you. So at the beginning, no significant differences, but at the end, almost completely taken out for imazapyr, glyphosate, and aminopyrrolate. So, just another visual for you. Control, lots of green, happy, healthy knotweed. Glyphosate, almost completely gone, just some struggling stems. Aminopyrrolate, it kind of grew up and then it curled at the top because it couldn't leaf out. And then imazapyr, where some knotweed appears to have snuck in, so I must have missed a spot, so you just have to treat that again to take it out. So just let's have a discussion. So both imazapyr and glyphosate can cause stem density reductions when you apply it in the fall as well as the peak height. Using aminopyrrolate, however, I think it'll work more consistently in the fall. However, further verification should be done to do that because it's nice to have more herbicides in a variety of windows. Aminocyclic is not effective for achieving stem density reductions. However, I have to give it some credit because what it can do is significantly reduce average stem height. So what we did is we measured 5 stems in the plot and then we averaged it out, ran the ANOVA. What you see is that aminocyclic did significantly reduce the stem height. However, imazapyr, aminopyrrolate, and glyphosate sort of do it better and you get the density reductions. So, I mean, it's kind of up to you if suppression is what you're looking for. So let's just talk about the advantages of different windows. So for the peak height, you're getting a treatment in early in the growing season, and you ensure some herbicide makes it down to roots. However, growing native plants, if they're alive, might be adversely affected by spray drift, and if there are birds nesting in the area, which is a kind of a common thing with knotweed, you might wind up breaking the eggs, and that's not good. But with the fall, you might run into issues where if there's an early frost or a hard one, it might prevent herbicides from reaching the roots. You'd need about 2 weeks, hopefully. So you just need to time your application carefully and base it on where you live. But the advantage of maybe using the fall is that nearby native plant seeds might have a better chance to grow 1 year after treatment due to the reduced knotweed, and birds are usually done nesting by that time of year, so you'd be reducing your impact. So I've got a bit of a wish list here. So imazapyr currently doesn't have registration for treating Japanese knotweed in Canada, but like in the future, I would like to see a registration for like near building foundations, maybe parking lots, like heavily infested areas where there's nothing left, as well as near critical infrastructure. The other two, glyphosate as well as and aminopyrrolid, have registrations already in Canada, so they're very well-rounded herbicides that can be used in a huge variety of areas. So let's apply what we've just talked about to a bit of a case study. So Sambro Island is an important estuary habitat, so lots of birds nest there. I was contacted because there was a knotweed stand on the island that had been starting to spread, and birds were averse to the area. They would stop nesting. So they were concerned about the spread impacting the habitat. So what we did is we went out there and we just kind of looked at it, and we kind of came up with a bit of a recommendation. So in the first year, you'd do a fall spot spray to try to hit the knotweed hard and reduce its stem density for the following year. And then in spring, you'd transplant local nearby native grasses back into the area. You continue monitoring throughout the summer, and then fall of that year, you'd do a spot application of aminopyrrolid, because aminopyrrolid is selective for grasses. It won't hurt them. So that way, you're providing selective pressure against the knotweed, and you're helping the grasses grow. So in conclusion, we can validate the hypothesis applying herbicides during peak height as well as the fall can significantly reduce knotweed stem density. In Canada, Arsenal Powerline doesn't have that registration, but it would be very useful to have for heavily infested areas. Using glyphosate and aminopyrrolid should be recommended for knotweed management in appropriate zones. Just some acknowledgements. I need to thank my supervisor, Dr. Scott White, my committee members, Dr. Nams and Dr. Abbey, Kelly Finnegan for providing the South Maitland location, and the Nova Scotia Department of Transportation and Infrastructure Renewal for funding this work. If you would like more information about Japanese knotweed research in Nova Scotia, you can find me on Facebook at Japanese Knotweed Research Nova Scotia, or email me. And here are my citations, and I'm happy to take your questions now.
David.
So Tyler, you said probably more went into the roots in the peak than the fall. Can you confirm that in terms of how you observe?
I can't really confirm the quantity of herbicide that goes down. It's something that would be very difficult to measure. I just suspect that if you're going in at peak height, you're definitely getting something down because you have the whole summer for herbicides to be translocated. But in the fall,
just more time.
Yeah, that would be the big thing.
And one more, with the fall, would have flowering already?
In the fall, flowering would have already been done. So towards the end of September, kind of second, third week, seed sets kind of already happening in Nova Scotia.
So the advantage that might be they've used energy flowering, so they're more...
Yeah, they may be more susceptible as a result.
Yes.
One of the areas you indicated as a problem is on the riverbanks and areas like that with glyphosate and other pesticides not being allowed within 1 meter of water's edge. How do we control it?
That's going to be a tricky question. So I guess in the future, we're going to have to figure out what's an appropriate way to get those herbicides into plants. So injections might be a possible way to do it, because that way you're going directly into the stem and there's less risk of it going directly into water. But like, I would recommend getting as close as you can to that river. But that sounds really bad with the spot spray, because injections are very, very laborious and they're very difficult to do. And if you miss something, it'll come back. So it's just important.
All right, thanks, Tyler. We need very quick one.
Okay, sorry.
I can't. The question will be quick, but I can't promise the response. So, what's the potential for biocontrol of this species?
Yeah, so it's my understanding that biocontrol trials are underway, I think in British Columbia, and I think they have been allowed for controlled release. Biocontrol would be good, but like in acute infestations, it's probably not going to be good enough. Like unless you're getting like stem density and height down to like maybe like 25 centimeters tall and like maybe 5 stems per square meter, like it's still going to have a really large impact. So that would be my thing. So definitely need some acute management plans.
All right, thank you. I need the microphone, Tyler. He's trying to steal the equipment. I know. Our next speaker is Eva Zabin from University of Waterloo. She works with Roy and Fraser in Wisconsin, and will talk to us about exergy as a physiological